Part C, Managing Fieldbus Projects. Devices on a bus. In the planning phase, it is crucial to determine the number and types of devices that will be connected to a fieldbus. The total number of devices on a bus should be between 2 and 32. Each device must be compatible with the fieldbus system to ensure seamless communication and operation. Proper planning ensures that the fieldbus network can handle the required devices without overloading the system or compromising performance. Wiring design. The wiring design must follow specific guidelines to ensure proper signal transmission and system reliability. The IECSA standard specifies the use of a twisted pair of individual shields type A with 18 AWG wires. The overall cable length should not exceed 1900 meters, and the overall spur length should not exceed 120 meters. The wiring design should account for these limitations to ensure that the signal quality remains within acceptable parameters throughout the network. System design. System design involves integrating all components of the fieldbus network to create a cohesive and functional system. This includes designing the layout of the network, selecting appropriate devices, and ensuring that all components are compatible and can communicate effectively. The system design should also consider future scalability, allowing for easy addition or upgrade of devices without major modifications to the existing network. Proper system design ensures efficient operation, ease of maintenance, and long-term reliability of the fieldbus network. Installation. The installation phase involves the physical setup of the fieldbus network, including mounting devices, running cables, and connecting devices to the bus. It is essential to follow the wiring rules and guidelines specified in the planning phase to ensure proper signal transmission and system reliability. This includes adhering to cable length limitations, using the correct type of cables, and properly shielding and grounding the cables to prevent signal interference. Commissioning. Commissioning is the process of configuring and verifying the operation of the fieldbus network after installation. This involves setting device addresses, configuring communication parameters, and ensuring that all devices are correctly recognized by the network. During commissioning, each device's functionality is tested to ensure it operates as expected and communicates properly with the network. Any issues identified during commissioning should be addressed and resolved to ensure the network's stability and reliability. Startup and test operation. The startup and test operation phase involves powering up the fieldbus network and performing initial tests to verify its operation. This includes checking for proper communication between devices, verifying that data is correctly transmitted and received, and ensuring that all control functions operate as expected. During this phase, it is important to monitor the network for any signs of issues, such as communication errors or device malfunctions, and address them promptly. Successful completion of this phase indicates that the network is ready for normal operation. Operation phase. Control operation. During the operation phase, the fieldbus network is actively used to control and monitor the industrial processes. Control operations involve executing the control strategies configured during the commissioning phase. Function blocks in the field devices communicate and work together to perform the desired control functions. The system should be continuously monitored to ensure that it operates within the specified parameters and that any deviations or issues are promptly addressed. Regular maintenance and updates may be required to keep the system running efficiently and to adapt to any changes in the industrial process or operational requirements. Maintenance phase. Device alarms. Device alarms are critical for maintaining the reliability and safety of the fieldbus network. Fieldbus devices are equipped with self-diagnostic capabilities that generate alarms when an issue is detected. These alarms can indicate various conditions, such as device malfunctions, communication errors, or process deviations. It is important to monitor these alarms continuously and respond promptly to address any issues. Effective alarm management ensures that potential problems are identified and resolved before they can impact the overall operation of the network. Replacing a faulty device. Replacing a faulty device in a Fieldbus network involves several steps to ensure minimal disruption to the system. First, the faulty device must be identified and isolated. The replacement device should be configured with the same address and parameters as the original device to ensure seamless integration into the network. Once the replacement device is installed and powered up, it should be tested to verify proper operation and communication with other devices. It is essential to update the network documentation to reflect the replacement and ensure that the system remains accurate and up to date. Asset management involves tracking and managing the physical and operational aspects of all devices in the Fieldbus network. This includes maintaining an inventory of devices, monitoring their performance and health, and scheduling regular maintenance activities. Effective asset management ensures that all devices are functioning correctly and that any issues are promptly addressed. It also involves planning for future upgrades and replacements to ensure that the network remains reliable and capable of meeting operational requirements. Advanced asset management systems can provide detailed reports and analytics to support proactive maintenance and decision-making processes. Renovation phase. Addition of applications. The renovation phase often involves the addition of new applications to enhance the functionality of the Fieldbus network. This can include integrating new control strategies, adding new function blocks, or expanding the system to include additional devices. The process involves configuring the new applications, ensuring compatibility with existing components, and performing thorough testing to verify their operation. Adding new applications allows the network to adapt to changing operational requirements and take advantage of advancements in technology. Device upgrade. Upgrading devices in the Fieldbus network is an important aspect of the renovation phase. This can include replacing older devices with newer models that offer improved performance, additional features, or enhanced reliability. The upgrade process involves planning the upgrade, configuring the new devices with the appropriate parameters, and integrating them into the network. It is essential to perform testing to ensure that the upgraded devices function correctly and communicate properly with other devices in the network. Device upgrades help maintain the efficiency and effectiveness of the Fieldbus system and extend its operational life.